Hello guys, today we are going to discuss current branch analysis. So according to current branch analysis, the polarity of the resistor will be according to the current, according to the original current. So let's start from loop 1 and applying Kirchhoff voltage law. According to Kirchhoff voltage law, the algebraic sum of the potential rises and potential drop is equal to 0 inside a closed loop. Inside a closed loop is equal to 0. Now applying Kirchhoff voltage law, E1 minus V1, so V1 is across R1, and minus E3 plus V3 is equal to 0. Now putting the value in this equation, so E1 is 15 volt, V1 is 4 ohm with current I1, E3 is 20 volt, and V3 is I3, and R is 10 ohm. As we know that we have one node here in this circuit, so the current entering to that node is I1 and I3. The current leaving from that node is I2. So I2 is equal to I1 plus I3. So according to Kirchhoff current law, the current entering to a node is equal to the current leaving a node. Now let's simplify this circuit. If we further simplify this circuit, it will equal to minus 5 for I1 plus 10 I3 is equal to 0. Now if we further simplify this circuit, it will look like this, is equal to 5. So this is the simplified form for loop 1. So the equation for loop 1 will equal to 4I1 plus 10I3 is equal to 5 for loop 1, and I2 is equal to I1 plus I3. Now applying Kirchhoff voltage law in the second loop. So according to Kirchhoff voltage law, E2 with positive sign minus R2 plus V3 and minus E3 is equal to 0. Let's put all the value in this equation. E2 in this case is 40, V2 is equal to 5 ohm, current I2, current I3 with 10 ohm minus 20 volt. If we further simplify the circuit, it will become 60 minus 5i2 plus 10i3 is equal to 0. Now, as we know that I2 is equal to I1 plus I3, now I2 is equal to I1 plus I3. So here this is minus sign according to the current, so the potential across R3 is a drop, so we will put minus sign here in this case. Minus 10i3 is equal to minus 60. If we simplify this circuit, this equation, it will look like 5i1 minus 5i3 minus 10i3 is equal to minus 60. So the final equation for loop 3 is equal to 15i3 minus 60. So let's put the simplified circuit here. So according to this circuit, if we put these two equations in a matrices form, so it will look like this. Now minus 4, 10, minus 5, minus 15, I1 and I3. Now 5 minus 60. Now this is A, X is equal to B. According to Kramer rule, we can find I1 and I3. So let's find first the determinant of A. So if we are going to find, if we find I1, so I1 will equal to determinant of matrices A and determinant of this matrices. For I1 we replace column 1 with a matrices B. So if we solve this matrices, now determinant of the denominator is equal to 110 and determinant of the numerator is actually equal to 525, so which is equal to I1 is actually equal to 4.75. Now according to this, we found that I1 is equal to 4.75 ampere. Now for I3 we will find the determinant of this matrix 10 minus 15, and we will replace the second column with matrices B. So the determinant is, we know that the determinant of the denominator is equal to 110, and the determinant of the numerator is equal to 265. So I3 is equal to 2.4. So according to this method, we found that I3 is equal to 2.4. So according to this equation, I2 is equal to I1, which is 4.75, plus I3, which is 2.4. So if we add these two digits, so I2 is equal to 7.15 ampere. So I2 is equal to 7.15 ampere, I1 is equal to 4.75 ampere, and I3 is equal to 2.4 ampere. So according to branch current analysis, we found that all these currents is equal to this. So in this branch current analysis, we apply the following laws: Kirchhoff voltage law and Kirchhoff current law. So this is the end of the lecture. Thank you for watching.